least a little bit interactive. It'd be really helpful for the recording. Okay, here we go. Section 5.4. You guys have formulas, right?
Yes.
Help me out. Have you ever had to take a quiz or test on something that you just had to memorize?
Yes.
Oh, that's a thing in school? Where? I don't know. History? Where else? Vocab quizzes? Where else? Oh yeah, vocab, right? In Spanish and French and whatnot. Bible? Okay, how do you memorize things? Give me ideas. How do you study? You can't blow it all off. Flashcards, Quizlet, notes. What else? Notes. What do? Do you like read over them or like
notes
highlight?
in the phone, and then I like look over.
Oh, okay. So you have it around you, so you can keep on looking at it. That's a good idea. What else? Walking to class.
What?
It works. Using that time in between classes, right? Mr. Strike. How does he help you memorize? Singing it. And you're like singing it with other people, and so then everyone's memorizing it. It might annoy you, but it works. What else? Kelvin, Jaden.
Oh, I just write down what I need to memorize over and over again.
No, some people need to do that. Write it over and over again, right? You guys have seen the old movies where like the kid have to go up on the chalkboard over and over again. Like, it's because some people learn best by writing it over and over again. What else?
Study groups.
Study groups? Sometimes. Depends. But sometimes study groups help, right? Sometimes they're just epic failures, like group projects. Anyway, coming back. We have formulas to memorize. Section 5.1, is there a whole table that we have to get memorized? Yes. At the end of chapter 5, next week, the test is on 2 days. 1 day, just formulas. 1 day, problems, and I give you formulas. The just formulas part, I give you a section like 5.1. Reciprocal, isn't that the first section?
Yeah.
Reciprocal identities, I give you the title, and I give you 1 or 2 or 3 of them. Like, making them up literally off the top of my head. Cosecant u equals, you fill in. Tangent u equals 1 over cosecant u. 1 over sine of u is what you should write. Not 1 over sin, that doesn't help. 1 over sine of u, put the little u, then you're good. I'll give you a few reciprocals, and I'm going to write quotient. I'm going to give you 1 or 2. I'm going to write even and odd or co-function, and then write 1 or 2, and you fill in. I'm going to write sum and difference, 1 or 2 or 3, and you fill in. There are more formulas in 5.4. There are more formulas in 5.5. 5.4, you have to memorize all of these. They're the only new formulas. It's the section title. These are the only new formulas. 5.5, there are lots of them, but you only have to memorize some of them. And I'll make sure you know by tomorrow. That way you can be studying over the weekend going into next week, okay? So, formulas, you have to memorize them. You have to figure out what some of you just are like, okay, there are 6 formulas, I'm just going to read them over and 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 over, and hopefully they'll stick. Others of you are like, I know you're creative. So many of you are so creative in different ways. You're going to look at this and be like, well, if I really have to memorize it, let me try to figure out tricks. Let me try to figure out patterns. Let me try to figure out ways to help my brain remember, right? Has anybody, or can anybody, looking up here, find any sort of patterns to somehow simplify memorizing these 6 brand new formulas? Doesn't even have to be the whole formula. A pattern that you see.
The U is always before the V.
Say it one more time, Grace.
The U is always before the V.
Okay, good. In all of them, the U's always come before the V's. So the firsts always come before the seconds. Good. That's a trick for every single one. U's always come before V's. Jade, what else do you see?
Plus, minus, minus, plus. That's how I.
So if you're writing them in order,
Yeah.
he's looking at the signs, plus, minus, minus, plus. Now,
So I keep that.
plus, minus, minus, plus, that's kind of cool too. However, I actually have another way of looking at the signs. I'll share it in a second, but that is a good pattern. Trying to figure out how to get the pluses and minuses straight. And the dilemma is, if you don't have to write all 6, will you still remember it? That's the hard part. But that is a pattern. What else? Yeah.
For the sine ones, like sine and cosine, it's almost like you can flip them over the sine in the middle. Like it's sine and cosine, and then cosine and sine, so it's like reflected.
Good. There's like a reflection across the sign. And you also pointed out with the sign ones, aren't these 6 kind of grouped into categories? Aren't the 6 really just pairs of 3? Sorry, pairs of 2, 3 pairs of 2. Now, you ready for my tricks? Maybe they'll help, maybe they won't. And to be honest, I haven't really come up with a great way for the tangents, and no kid that I know of has really come up with a great way. Although Michael Gerges in period 2 came up with a song, he tried singing it. His class somewhat appreciated it. Maybe just made fun of him. But anyway, it did work for him, and I think, hopefully, he'll keep singing it and remembering it. But, for me, I saw the signs too, Jaden. That was one of the first things I saw. And so I think the signs stay the same. Cosine, the signs change. You guys see why it's a way to remember? Sine same, cosine change. But what do I mean? U plus V, the sign stays the same. Sine stays the same. Cosine, the sign changes. And that's actually, oh, I wish that worked for tangent. Isn't tangent sine over cosine? Now it's a little more complicated if we were to actually take all of them and try to do this and show this, but it is sine over cosine, quotient property. Okay, sine, the sign stay the same. Cosine, the sign changes. Oh, that works. Look at all the signs, the sines, the cosines, and the tangents. Here's the other way I remember it. You guys know prefixes from English, right? Prefixes are little like beginnings of words that have meanings, give additional meanings to the word that's about to follow, the root word. Where's a prefix up here? There's only one. You guys haven't realized it's a prefix. What's co mean? With or together. Usually, with or together. Now, technically, mathematically, co-function, and actually has to do with the whole co-function properties. But co in English we would think with or together. How on earth does that help us? Both signs are with each other and the signs are with each other. What? With or together. The cosines are with each other and the signs are with each other. What? Well, if that's the cosine, what's the sine? It's the other one. They're not together. So, cosine. Cosine, sine. Cosine, sine. 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 Other one. Cosine. Cosine, sine. And like Caitlin said, there's that symmetry. So sine, cosine, you do it the other way. Cosine, sine. And like Grace said, all the U's, then the V's. All the U's, then the V's. Now, tangent, once again, I don't have a great way. If you guys think of a way, let me know. And if worse comes to worse, we'll try to get Michael Gerges to sing. I don't even remember what melody he was singing to. But I was like, well, not everybody's musical, right? So maybe not everyone can come up with a brand new song like Mr. Strike does. But, do you guys know in the olden days, hymns used to be new once upon a time? What do I mean by hymns? Anybody in the church? Hymns are like the old-fashioned songs, right? Like Amazing Grace and Come Thou Fountain. We sing it every now and then. Wish it was a lot more often. But I love some of the old hymns. But the old hymns used to be new. And some of the original hymn writers would take little jingles from the bars that everybody knew just from hanging out and being on the street and like with us, like walking in like shopping centers and whatnot. In the olden days, it was like walking down the street and then like in the bars is usually where the music was, where people were playing music. They would take some of those jingles and they put these worship lyrics, these hymns into that music so that people already knew the music and you're just putting in new words. You can do that with formulas too. So that's what Michael did. He stole, I don't even know what, you can ask him. He stole some song and he threw it in. And it was a little rough, it was a little choppy. It wasn't exactly super, I mean he did it in 5 minutes. But anyway, you can think of, if that's how your brain memorizes, start singing your formulas. Now Corey tried it with forever cards and she was making up new songs for every forever of these formulas you have to memorize in calculus. If that's how your brain works, use it, do it. But here's the idea, guys. We have new formulas. We got to use them. So let's figure out what this whole page was about. Does anybody have a calculator? Okay. In your calculators, I want you to plug both of these in. There's a way to do it by hand, but just real quick, I want to show you something really fast. So let's see. Radian mode, right? Because there's pi's. Going to radian mode. Maybe you're going along with me. Sine of 7 pi over 6 minus pi over 3. Careful, this all needs to be inside the sign. Sign of that whole shebang. Okay, what'd you guys get?
0.5.
Ah, I got 0.52. I should say also. So sine of this, 0.5. How similar does this guy look to that guy?
Yeah.
Very similar. And anybody who's taken Algebra 1 could make this mistake. Anyone in Algebra 1 or who has taken Algebra 1 could make this mistake of thinking that these two are the same. Now, hold on, plug it in. Those of you guys with calculators, plug it in. You can do it by hand, we're going to show it in just a second, but plug it in. What'd you get for this guy? I got that too. 6.6-ish? Are they the same?
No.
Why would anybody who's taken Algebra 1 think they're the same if they weren't educated further?
Because you can distribute the sign.
Yeah, distributive property, right? There's a parenthesis, there's something outside the parentheses, you take something outside, and what your brain wants to do is bring it in. But here's the question, does it work with sine? No. Guess what? Do you think it's going to work with cosine? Tangent? No. Because the only way to break up when you have sine of what we would call a composite argument, but you guys just call it a sum and difference formula. The only way to change how this looks, sadly, is using that formula. The only way to break this up, the only way to get to sines of u's and sines of v's, you have to use this entire formula. It's the only legal way. So our calculators already told us this doesn't work. My silly way of remembering it is never distribute sin. Life lesson, actually. But you shouldn't be distributing sin. That's not a good thing. If you go distributing sin, you're not seeing him as sine. Remember what I've been saying all along? It's not sine times. It's sine of. 7 pi over 6 minus pi over 3 is stuck within the sine function, and sine does not behave like multiplication. So, don't distribute sin. It's illegal. It's not going to help. We could go deeper into that just for life. But, for right now, let's think about the trig. Another way of looking at it is, if I was to try to put those two together, which I actually could do in this case, I could go ahead and do sine of 7 pi over 6 minus. There's no reason I have to use the big nasty formula for this one, and here's the reason why. I can get a common denominator. I can just put those two together. There's no reason to distribute. If I was to get a common denominator, I would have 2 pi over 6. I subtract the 2. What would that be, guys? Sine of?
5 pi.
Good, 5 pi over 6. I have to ask myself the question, wait, is that unit circle? Hopefully the answer is yes. 5 pi over 6, second quadrant, all students, sign is positive. Visual people, it's up a little, so 1/2. Cheater chart people, it's a 30 degree. 3, 2, 1, 3 per sign. Square root of sign counts up, 1, 2, 3, that's a struggle. Sign's the first column, 1, 2, 3, 1 is the 30 degree. Either way, you get it to be positive 1/2. So first of all, there was no reason to even stress about that. Put it together, it's a unit circle value, and then you solve. But if we were to break it apart, this could not be how we do it. Because what this would be, sine of 7 pi over 6, first of all, we'd be in the third quadrant, down a little, that'd be negative 1/2, minus sine of pi over 3 would be square root of 3 over 2. Maybe you guys realize. Which would end up being this decimal. These do not match. They are not the same thing. So we have to realize if we were to ever need to break up something like this, if putting it together didn't work, this would not be the way to do it. Okay? So, life lesson from today, don't distribute sin. Thank you. or cosine, or tangent, or secant, or cosecant, or cotangent. But sin's the easy one to remember. Now, this one, we didn't need to break it up. It was fine, 5 pi over 6. This one, let me show you why it's not quite as nice as the last one. This is a hint that's been given to you in the problem. The directions tell you where to go. Bless you. Here's what we're trying to find. We're trying to find sine of 11 pi over 12. And actually, to be honest, according to the directions, we're also trying to find cosine of 11 pi over 12. We're also trying to find tangent of 11 pi over 12. Let's focus on sine to begin with. Why is this bad? If we're not allowed to use our calculator.
It's a unit circle.
Yeah, it's not a unit circle. Now, can you tell me where it is? Hopefully. What quadrant? Second. It is almost a whole calzone, but remember, a calzone's only a half. Pi is only a half, and it's a little bit less than just a 12th. Missing just a baby piece, actually probably smaller. It's missing just a little tiny piece. Pi over 6 would be up here, pi over 4, pi over 3. It's missing just 1/12 of that calzone. 1/12 of that pi, 1/12 of that half circle. So I know where it is, I just have no idea what the sign is, besides being, I don't know, something between 1 and 0. Something less than 1/2. Because it's lower than pi over 6, or I should say 5 pi over 6. But that's where their clue comes in. Their clue says, hey, never fear. Guess what? 11 pi over 12 actually comes from 3 pi over 4 plus pi over 6. So you get common denominators. Times 3 over 3 times 2 over 2. 9 pi over 12 plus 2 pi over 12 would be 11 pi over 12. So what they're saying with that clue is, hey, guess what? You can split them up. And why do you think they're showing us this? Why do we like 3 pi over 4 and pi over 6 better than 11 pi over 12? A, they can make common denominators, so it is a legal way of splitting up, but B, they both are in our, now here's the struggle. Should I distribute sin? No. So the only legal way to go, now I have this formula memorized, you don't. It's written in the beginning of your notes. The only legal way to go is sine of B. My way of remembering, sine, the signs stay the same, so I put a plus. Sine. I start with sine of the first one, u. But I need to go not with sine, it's not with or together, it's other sine function. It's cosine. Then like Caitlin said, the symmetry. Sine, then cosine, now cosine. Then sine. Some of you like patterns, some of you that'll be enough. Many of you, it's not enough. Studying, flashcarding, highlighting, singing, figuring out something is going to be better for you. But for me, it works. And for you, to at least see how I got this. The formula in your notes, right? Now here's where we need to take it piece by piece. We need to say, wait, each of these trig functions, guess what? I can find what they are. I can find what they equal. 3 pi over 4 is a 45, right?
Yeah.
In the second quadrant, sine is a positive value. But I'm going to find that positive value and plug in. I want to find what is sine there, what is cosine there, what is cosine here, what is sine there. I want to plug in what they equal. So a 45 degree, sine is always root 2 over 2. In the second quadrant, it's a positive. The goal today is not to teach you the unit circle, but just to say, hey, here's what they use. Cosine of pi over 6. Who's already beaten me there? 30 degrees. First quadrant, good. So cosine's a positive. Careful. Sine. 1, 2, 3. Sine is 1. Cosine is 3, 2, 1. Cosine. Yeah, cosine's the big one. Sine's 1/2. Cosine is root 3 over 2. Oh, hey. Sine is 1/2. I need him also, huh? There you go. Now 3 pi over 4, aren't sine and cosine the same thing? Except, second quadrant, is cosine positive or negative? But if you're able to know your unit circle, you can go from that nasty big old expression with sines and cosines and angles to just numbers. Now, I know you don't like the numbers, there's radicals and denominators, but they're just numbers. What do we do with numbers? Whatever the operation said. PEMDAS, multiply, multiply, then add. So root 2 and root 3 is root 6. 2 times 2 is 4. Negative root 2 times 1 is negative root 2. 2 times 2 is 4. What can I do when the denominators match? If the radicals don't match, can I combine like terms? No. 6 doesn't have a perfect square, 2 doesn't have a perfect square, nothing else I can do. Those are under radicals, this one's not, so I can't even reduce. I'm done. What you could not have done from the beginning, 11 pi over 12, who's that guy? He's not from my unit circle, became possible by using the formulas. Since they both have radicals, I can multiply the two together.
You just couldn't add there because they weren't the same.
Because they went the same time.
Oh, but if it's multiplication, you can't.
Addition has to be like terms, not to have the same particle. Now guys, cosine, guess what? Super similar. Because you're still going to split them up. And guess what cosine has? His own version of a formula. Yeah? And that own version of the formula I could go ahead and plug into with the u plus v. And it would look an awful lot like this one. Just it'd be co, sine, sine. So these would be in different orders, but I'd still be multiplying and adding and putting together and then stopping. Does it make sense why I said dot, dot, dot? Tangent, actually the same thing. Just his formula is a little bit nastier. So we're still going to do the same thing of splitting this guy up with the hint or the clue that they gave us, looking to the table or the formula to figure out what formula he has. At this point, Michael started singing his song. I don't know if any of you guys have come up with a song yet, so I'll go ahead and help out a little bit. It's going to be tangent of u plus tangent of v all over 1 minus tangent of u tangent of v. Whew, gotta simplify that. Now it seems nasty, unless you know the cheater chart. Because the cheater chart says, wait, we know all the tangents. Square root of 3 over 3, 1 square root of 3 was 0 and undefined. Okay. So pi over 4, that's a 45, right? Square root of 2 over 2 is the sine. Square root of 2 over 2 is the cosine. Divide the 2. Square root of 3 over 3, 1. 1 is the 45. But second quadrant, tangent is not positive. Plus, pi over 6, that's going to be the 30. That's the first one. Square root of 3 over 3. And once I find them, I can go ahead and plug them in everywhere. Now guys, do you think the book would say you need to simplify right now?
Yes.
Yeah. Do you see a complex fraction that you need to deal with?
Yeah.
Could you do common denominators multiply by the reciprocal?
Yes.
Could you do my cool nifty trick if you like it and multiply top and bottom by 3? Yes. You would need to simplify, but that's the right answer. You just need to simplify it to make it look pretty like the back of the book would show. Does that make sense? Okay. We've done some examples today. We introduced a lot. I tried to give us motivation to take responsibility of our learning, but we have some more to do tomorrow. Some of it will be evaluating. Some of it will be playing with we're going to say playing with triangles, basically these types of problems. And then we have some T proofs. But we're not developing any new skills. What are we doing? Learning how to use new formulas with the old skills. So my guys who were not totally caught up on 5.3 last night, catch up. Don't fall further behind. Those of you that are all caught up, 5, 4, go through a little bit. I'll finish it tomorrow.
Can I grade my graded thing on Friday?
Thanks, guys.